when you have a power to a power, you're talking about a base with an exponent that's being raised to a power. It has an exponent on it. Exponent to an exponent. Power to a power. When you have something like this, well, let's break down this problem and see what it would look like if we expanded it out. To expand it out, first I remember inside the parentheses, I have 2 times 2 times 2. That is 2 to the third power. And then we're squaring that. Well, that would be the same as saying 2 times 2 times 2 times 2 times 2 times 2, because when you're squaring it, you're multiplying it by itself. So this would be 2 cubed times 2 cubed, which is 2 cubed squared. Well, that has a total of 1, 2, 3, 4, 5, 6 2's being multiplied. So this is all the same as saying 2 to the 6th power. Well, how would I get that 6, that same 6, from this 2 and the 3? Well, here's 3, here's 3. I multiply it by 2, and I'm going to get that 6. Turns out when you have a power to a power like this, you can multiply the exponents. So x to the a to the b power would equal x to the a times b. Or in our case up here, we would have 2 to the third squared is equal to 2 to the 3 times 2, which is going to be equal to 6. So we get 2 to the 6 there. And 2 to the 6 would happen to work out to be 64. Here are 2 examples. Let's work these out. Here we have x to the 4th to the 3rd power. It's power to a power. So we're going to multiply the exponents. So we have x to the 4 times 3, which is going to give us x to the 12th power. And that's a simplified version of the original expression. This is simplified because we don't have power to a power, and we don't have parentheses. You should not have any parentheses in a simplified expression. Now, the next one here is a little more complicated. Let's do the breakdown on this one. If I do 3a to the 5th squared, that's like saying 3a to the 5th times 3a to the 5th, which means you are going to be doing 3 times 3 and a to the 5th times a to the 5th. Well, we know when we've got this situation, we're going to be multiplying the exponents. And here we're multiplying 2 like bases, so we would add these exponents. 5 plus 2 is going to give me 10, which is the same as the 5 times 2. Then we have the 3 times 3, which is 9, which also happens to be equal to 3 squared. So this is going to end up being 9a to the 10th when you simplify it. When you have a whole number to a small exponent, you should simplify it by actually executing the exponent on that number. So the answer, the final simplified answer here is the 9a to the 10th, which we can get by expanding it out like we did here, or by distributing this exponent to every factor inside of the parentheses. Okay, let's expand this one out just so we can see the expansion again here. This is going to be 4a squared b cubed times 4a squared b cubed times 4a squared b cubed. Now at this point, all of this is being multiplied. Since it's all being multiplied, we can rearrange the order using the commutative property. So we can change this to 4 times 4 times 4, bringing the numbers, these 3 numbers together. Then we bring the a's together, and we get times a squared times a squared times a squared. Then we bring the b's together, and we get times b to the third times b to the third times b to the third. Now we can simplify this by combining the four fours. 4 times 4 times 4. Well, 4 times 4 is 16, times 4 gives you 64. When you have like bases being multiplied, you add the exponents. So 2 plus 2 plus 2 is going to give you 6. So you end up with a to the 6th. B cubed times b cubed, b cubed. You got to add the exponents. You get b to the 9th. This would all be the same as having gone from here, the original part, gone from the original here, and distributed that cube to each of the factors inside, which would give you 4 cubed times a to the 2 times 3 times b to the 3 times 3, because power to a power, you multiply the exponents, and you would end up with the same 64 a to the 6, b to the 9th that we ended up with before. Okay, now you give these three a try in your notebook there. Go ahead, pause the video, write these down, give them a try. Welcome back. To answer this one, the first one would be x to the 3 times 10, which would give you x to the 30th. Over here, to simplify this one, you'd have b to the negative 2 times 4, and that is times, would give you b to the negative 8, but a simplified expression should not have a negative exponent. So remember, negative exponents become positive when you move them to the bottom of a fraction. So this would be the final answer on number 2. Number 3, the exponent is only going to work on the stuff in parentheses here, so it's not going to affect the a at all. So the a will stay there. B will become b to the 2 times 3, which is going to give you a b to the 6th power. And that's your final answer there. All right, now let's say you have a power to a power with fractions involved, like this problem here. Here we have a fraction with exponents in it, and an exponent that goes on the fraction as a whole. Now, square, we should know that that's going to be this number inside the parentheses, the 1 to the 7th over 2 to the 3rd, times itself, 1 to the 7th over 2 to the 3rd. And we should know when multiplying fractions, it's the top number times the top number, numerator times numerator becomes a new numerator, and the denominator times the denominator becomes the new denominator. Well, these would simplify because you're adding the exponents. This would become 1 to the 14th over 2 to the 6th, because you would add those exponents. Now, you might be tempted to subtract those exponents here, but these are not like bases, so we cannot subtract those exponents. But we can simplify it because these are number bases, and we can work this out. Now, first, you might think this is a really large exponent. You can't work that out. But 1 times 1 times 1 times 1 times itself, no matter how many times, is going to end up being 1. 2 to the 6th is, well, 2 to the 3rd is 8, and 2 to the 3rd is 8, so 2 to the 6th is going to be 8 times 8, which is 64. So this works out to be 1 over 64. Now, the power to a power says that we should be able to multiply this exponent here, but which exponent? There's 2 exponents here. Well, I'm saying you need to multiply both of them, because you know when you multiply top times top, 2 times 7 is going to give you the 14. 2 times 3 gives you the 6. So you can go straight from this to our part here by multiplying both the numerator exponent and the denominator exponent. Let's try another one. Okay, let's say we have 2 thirds. Let's put a square on this, and let's just do a power of 1 on that. And we'll say this is to the negative 2. All right, now what I said here is we should be able to multiply the exponents. So this becomes 2 to the 1 times negative 2 over 3 to 2 times negative 2. I don't need that extra set of parentheses there, but so that's going to be 2 to the negative 2 over 3 to the negative 4. Well, 2 to the negative 2, I would have to move that to the bottom, the denominator, to make it positive. 3 to the negative 4, I have to move it to the top, the numerator, to make it positive. So I end up, at this point, with a 3 to the 4th on top and a 2 squared on the bottom. 3 to the 4th would be 3 times 3 times 3 times 3, which is going to give you an 81. 2 squared is 4. Is that completely simplified? Well, as far as exponents are concerned, yes, but it's a top-heavy fraction, so we should do the 4 goes into the 81 to convert to the mixed number. It goes in 20 times with 1 left over, so we end up with 20 1/4 as the final answer. Still confused? Let's try a couple of more simplified ones here. Here we have x squared to the 5th power. That's the first question here. To do this, we are going to multiply those exponents to simplify, which will get rid of the parentheses. So this will become x to the 2 times 5, which makes sense because we're talking about x times x. Well, we're talking about x times x times x times x times x times x times x. You can do that 5 times. So it's 2 x's times themselves 5 times, which is going to end up being 2 times 5, which is going to give you x to the 10th power. Now that is simplified because there's no negative exponent, there's no parentheses, there's no duplicates of the variable. This is a simplified version of this original expression. Let's try the second one here. This would become a to the 4 times 9. We can't leave it like that because that's got multiplying there. We should do that multiplying. 4 times 9 gives you 36. So this is your final simplified answer for the second one, and this is the final simplified answer for the first one. Okay, a couple other examples here with the fractions. These are a little bit simpler here. In this case, we are going to be taking this exponent and distributing it to both the numerator and denominator here, so that this will become 2 to the 3rd power over 5 to the 3rd power. Since these are both numbers to small exponents here, we can actually simplify it further by doing the 2 to the 3rd, which is 8. 5 to the 3rd would be 5 times 5 is 25, times 5 again, you would get 125. Is there a common factor between 8 and 125? No. So that is your final answer on that one. All right, the next one, we're going to simplify it by multiplying those exponents. 4 times 2 over y 8 times 2, which would give you x to the 8th over y to the 16th, which cannot be simplified any further. I know it's very tempting when you see this 8 and this 16 to do something with them, and to see the division here, but these are different bases, so you cannot subtract those exponents. There's nothing you can do with this to simplify it any further. This is the final answer. Okay, let's summarize here. If you have a base raised to a power that is raised to another power, or a power to a power, you would end up doing the multiplying those two powers, multiplying them to simplify it. This would become x to the ab. Putting the two next to each other is multiplying. All right, now if we had a fraction, we had x, y, a, b, and raised to the c power. This is going to become x to the a times c over y to the b times c. And that is your final answer on that one. That's it. That's it. That's your final answer. That's your final answer here. Hopefully this has been helpful, and I'll see you in class.